Good morning, good afternoon, and thank you for joining us today. And thank you for the opportunity. So, let me introduce myself. My name is Ariana Ingga, and I'm the representative from our team with research title The Potential of Flip-Flop Waste as an Environmentally Friendly Sounds Absorbing Material. In the next few moments, we will journey together through the challenge posed by environmental waste, the significance of sustainable materials, and the innovative strides that can be made by leveraging unconventional research. It is a great pleasure that I can stand here before you to shed light on a topic that holds promising potential in address both environmental concern and the ever-growing needs for a sustainable solution. Our focus today revolves around a material that might not immediately come to mind when thinking about environmental impact, like flip-flops. Yes, just up ubiquitous, colorful sandals that often find their way into our daily lives. However, what if I told you that this seemingly inconspicuous item could play a vital role in contributing to environmental sustainability, particularly in the domain of sound absorption? The title of our research is The Potential of Flip-Flop Waste as Environmentally Friendly Sound Absorbing Material. This topic invites us to explore the uncertain territory of repurposing discarded flip-flops into researchable material that not only address the issue of waste but also serve as a sustainable solution for sound absorption. And as we know, the material that have cavities, several example rubbers, have the potential to become sound absorbing materials. And one of the rubbers waste that is often found is rubber flip-flops. And flip-flops are the one of the waste that have the potential to be processed into acoustic panels. Since this waste is often found in Indonesia, especially the one that is made from a mixture of natural rubber and EVA, ethylene vinyl acetate. So that's why this research is very important because from this research we can find out the sound absorption coefficient weights of flip-flops as a basic material in order to make environmentally friendly acoustic panels. And for the background literature, we use research title Sound Absorbing Properties of Material Made of Rubber Crumbs as one of our reference. And from this article, we know that rubber can be used as sound absorbing material. Rubber can work well at blocking sounds because it has add mass to the surface and stopping sound wave from escaping through walls and ceiling. And the goal of this recent paper is to analyze the influence of such parameter on the normal incandescence absorption coefficient of several prototypes. And the result is the best performing sample is one with compaction ratio equal to 20% and the final thickness equal to 9.5 centimeters. And for the method, we use simulation and modeling methods. We make like two samples with different size particle size, 3 millimeters and 7 millimeters, with 3.5 cm for the thickness of both samples. And we make it by mixing up the flip-flops rubber particles and the binding material as neoprenic glue. And for the testing, we use impedance test. The test is carried out by transmitting sound waves start from 100 Hz until 1600 Hz. And the result is uh, the sample testing change in sound absorbing coefficient with average of more than 0.2, so the material can be classified as sound absorbing material. It was found that both samples can absorb sound well at frequency around 1000 until 1600 Hz. And the second result, the frequency absorption coefficient result of 1020 Hz has a very drastic increase of 0.38 from 7 millimeters particles, which shows the sample works at high frequency. And for the discussion, the test result of the two samples show that the coefficient value changes significantly, so it could be concluded that the particle size, humidity of the adhesive material, and sample density influence the panel absorption ability. The panel absorption capacity was started to be quite good, and average of 0.21 and 0.31. And from this table, you can see the result comparison between both samples. And as we can see, the bigger particle works better than the small one. And so we now at the conclusion. We have the conclusion from the research data and sample testing has been carried out. The following conclusion can be drawn. The first conclusion was particle size of 7 millimeters have higher sun's absorption coefficient than particle with size of 3 millimeters. And the second conclusion is the factor that influence the sample sun's coefficient are the density, level, sample thickness, sample hardness, humidity, and dryness level of the binder in the sample. And the last conclusion is that the material from flip-flop waste has the potential to become an environmentally friendly sound absorbing material based on the material requirements as a sound dampening material if it meets the sound absorption coefficient above 0.159. However, it will use function better at high frequencies because the NRC of the two samples only reach 0.21 and 0.31 in low to medium frequency testing. And the last one, this is the reference that we use for our research. So that's all. Thank you for listening to my presentation, and may our effort lead to a future where even the most unexpected material contribute to well-being of our environment. And thank you, and let us continue the journey of the sustainable exploration together.